Hey everyone. All right, I'm going to go over some of the climate stuff that we've been talking about for Alaska NRCS work. All right, so the basic idea here is to summarize um, PRISM, or actually in this case, SNAP climate data for an MLRA or for specific map units. So we'll start working with an MLRA. So we will create an object called AKMLRA. Um, this file, you put in the path here, and this comes right out of the Alaska ESD developer um, teams team. So yeah, this is the MLRA shapefile. So we load that. I put my cursor in here, hit Control Enter, and that runs that line, brings me to the next line. And then on this line, I say that I'm interested in the MLRA 239. So I run that. Now down in the console, let's type AK MLRA. This will show us some of the properties of this object. One of those is the attributes of this shapefile. One of our attributes here is MLRA, and we're going to run this analysis on MLRA. So in this polygon ID here, let's put MLRA. Then we'll run that. And then I'm going to go through and run all of this because it's going to take a minute. Then I'll come back and explain some pieces of this while it's running. So here is the next piece of this. It's the directory where your raster climate data is located. So the way that I get my raster data and put the path in is by going to it. So this is raster data that is also in the AK ESD developer teams page. This is the precipitation data. It's from SNAP. Blaine can show you where that data is located in the teams page if you're not sure. So once you go to the directory in your file explorer, what I usually do is hit Shift, then right click here on the directory that we're in and go copy address. And then within these quotation marks, I'll paste my address. And then this puts backslashes in. And I don't know why this happens. It's very annoying, but R needs these forward slashes. So all these backslashes need to get changed to forward slashes. And usually what I do is Control F and I'll do a replace all. But this code actually has some purposeful backslashes here. So instead, you can highlight this, Control F, and then just do a manual replacement of these and don't remove those ones. So that's where you define your climate data that you're using. So we have our spatial, our shapefile for our MLRA, and then we have our raster data. This raster data is for the whole state. So within some of this other code, it is clipping the whole state worth of raster data down to just your MLRA of interest. So then we'll Control and Enter, and well, actually, sorry, we are already running all of this. So yeah, we're just kind of waiting for this to finish up. I will at this point mention, so we're running, we're going to summarize things in a few ways: a mean, a min, and a max. So let's look at I'll pull up Paint and kind of represent this a little bit. So we're summarizing things by the year in this analysis. And for each year, there's 12 months. And for each month, there's a raster, and we're running this on temperature, I believe. So let's say this is all for 1980, and this is month 1. and you have a raster here. And then I'll make another raster. And this is month 2, February. Uh, Now, let's say it's temperature data. So let's say, maybe this is -5, and this is -3, and this is -4, things like that, right? And in February, you've got some values, -6, -4, something like that, -2. So where I just showed you a mean, a min, or a max. Mean means that for each month, for this month of February, you're going to take the average across your whole study area for all the temperature data. So all of this is going to get combined into a mean value. And then all of this for February is going to get combined into a mean value. Um, Min and max would, let's say that this cell was really cold, and so was this cell. Min would go and grab your minimum value from each of these. Okay. So I think for the most part, mean is going to be your most appropriate in terms of combining things within a month within your study area. Then how you combine these two things, how you combine 1 and 2, I think there's more justification for combining things in a different way. You could um, take the average of all your months, and then you'd have kind of a annual average temperature, but you could have your annual minimum temperature by then at that point in the process of combining your months together, then taking a min value. And so, if we were just combining these 2 months, that min value would be, let's say that your average for this whole month here was -5, and your average for this whole month here was -3, then you're then using a mean to combine your months would take the average of the -3 and -5 to give you an average of -4. Your min would give you a -5, your coldest month, and your max would be a -3. So this code just finished up, so let's look at that. Um, Sometimes when you run this write.csv, it will give you an error, and let's just make sure. Okay, yeah, it's giving me an error because I have that file open currently, so we'll close it, and then we'll just run that again and look at that output. So let's see. That was in Matmare. Okay, so annual stats. Okay, so then we can see that we have, this is going to summarize things by year. And it's going to give you, for 1980, MLRA 239 as we specified. And then we have a mean, a max, a min, a sum, and a standard deviation. So these mean, min, max, mean, max, min, sum, standard deviation, those are actually reporting how the months are being combined. So let's go back to the code. So then here in this argument, we're saying this is how this is specifying which of the combinations uh, for each month. Okay, so we're saying, and what I think you generally want to do is take the mean of your whole study area for that particular month. And so right here, you're specifying in this argument, you're saying which of those you want to do. So I think you're normally going to go with mean. And then once you define that, um, you'll have your other summary statistics here, your mean here, max, min, sum. And so that's how you're then combining your different months. And so that's what you see in this final output, um, showing mean, max, min, sum. So this mean here is going to be your average temperature for the year of 1980. Max is going to be the warmest month for 1980, and min is going to be the coldest month for 1980. So these definitely have ecological significance. Um, and for some, for temperature, that's not really going to be a meaningful value, but for precipitation, it is. So now let's look at if we want to summarize things with map units, which is going to be a more accurate way of describing the climate associated with an ecological site rather than a whole MLRA. So we'll highlight this whole row, do Control Shift C. So that will bring that line back into use. And I'll do the same thing here, Control Shift C. So now we're loading map units, AKMU. This these map units, I think they're Sergo or sorry, StatsGo map units. Those are also in the AK ESD developer page, Teams channel. So you'll load that, and then you'll still load this MLRA, and we need to make sure that they're in the same coordinate system. So we use this project function and just make sure that they're in the same coordinate reference system. And then we're going to crop. So we're going to take the map units, which currently are the map units across the entire state, and we're gonna crop. I think the ArcGIS equivalent is clip. So you're gonna reduce all the map units for the whole state down to just where they occur in your MLRA of interest that's defined here. So we reduce that down. So let's start running this. And then let's look here. Then we'll look at AK MLRA down here, AK MLRA. So now we see that we have an area symbol, a spatial version, an MU sim, and an MU key. So whereas last time we ran this for an MLRA, we're now going to run it for an MU sim. We're going to, because we're summarizing things by map units. So last time we actually were running things on precip last time. I thought we were running them on temperature, but so if you needed to change this, you would change your directory, um, and I'll just run it on precip again. And the rest of this should all stay the same. We already talked about these are the three different ways of combining within a month, all the cells in the raster within a month. Then we define which of those we want to use. Mean, particularly for precip, mean's going to be the most logical one to use because we're going to sum things in the end. So what would happen if you used like min would be that it would take the minimum value. Let's see, it would take the minimum value for each month. So it'd take like -7 here, and then it would take -9 here, and then it would sum them and add them together, right? But those cells aren't even actually in the same place, they're in different places. So then you're kind of taking properties from disparate areas of your study area and combining them, which probably doesn't make a lot of sense to do that. So then, yeah, for precip, sum's going to be an important one. That's going to be your total precip for the year, but also max and min, the whatever month has the most precip. And for areas that have, droughty conditions at a certain time of year, that's a limiting factor. You've got min. So then let's look at the output of this. I already ran it. So I didn't run all this script right now. I have some of the results saved for this. So we can see here what the output would look like is now for 1980, we have 5 different lines, and it's each of the map units in our ML array. And for each map unit, you get all these stats of mean, max, min, sum, and standard deviation. And so let's say we have an ecological site that occurs in two of these map units. So what we really want to do here is combine these two. Um, and you could easily do this in Excel, but if you want to do it in R, um, and particularly if you have maybe a lot of different MU sims, it might be more useful to do in R. So what we would do is say, um, define our MU sims that we want to combine. So we'd put them in, we'd concatenate them together here. So we've got this map unit symbol and this map unit symbol, and they're going to be summarized together. So we'd take our output results here, um, which actually, let's put a 2 there. So like we looked at for 1980, 5 different map unit symbols. And what we're going to do here is filter that down so that it's only our map unit symbols. Sorry, let me put a 2. I just have this 2. This is an object that I stored previously. So yours is not going to have a 2, but I didn't want to run through all this code because it takes a while. So this is going to reduce your data down to just your map unit symbols of interest here. And then we're going to group it by year. So anything that's in the same year is all going to get summarized together. And then you use this summarize function. And this looks a little confusing because you've got mean 3 times in a row. But what we're saying here is we're going to create a new data frame. And there's going to be a column in that data frame called mean. And the values that are going to be stored in that new column is going to be the mean of this mean. So we're going to create a new data frame. Let's just see what it looks like. Oops. So a new data frame that has mean. So that's what that mean is right there. And that mean is taking the mean of this column here, mean. So it's taking the mean of these two values. We're combining all of the 1980s together, and we're going to take the mean of 33.6 and 32.9 for an average of 33.2. So I think a lot of times it probably makes sense to be taking means of things. So you're going to have different map units, right, that have different conditions. And then I think what probably makes sense is just to average them together. Whereas, you could take where we're taking the maximum temperature. So max is going to be the max in our original data frame, which let's just look at. So we had 1980, 2 different map units, and where we have max, that's for this year, for this map unit symbol, this was the warmest temperature for a particular month. So there's a chance that for some reason you would, instead of averaging these 2 map units together, you say, I'm going to take the warmest temperature that occurred throughout the year in any of my map units. And so if you wanted to do that, you could put max in here instead of mean. But hopefully that's clear. I'm not going to beat that too hard. But I think, yeah, for a lot of situations, you probably want to use the mean. And by doing that, you can calculate whatever other statistics you want. And that will provide you. And in addition, you also, for precip, you definitely want to do the mean. So sum, you would definitely want to do the mean of the precip because you don't want to be adding the precip from 2 different map units together. That's going to create too high of a precip. You actually want to take the mean of those 2 map units. So hopefully that's clear. If you guys have any questions, you can just ask me. All right, see if I can figure out how to close this thing down and see ya.